Have you ever imagined that electricity could become smart itself? In the past, detecting power outages relied on humans, and monitoring was manual and incredibly slow. But today, with technological advancements, smart devices have emerged that can automatically detect faults in electrical grids. These devices don't just detect, they send information instantly to control centers, pinpointing the location of the fault with incredible accuracy, down to a few meters. This means that power outages can end much faster, and our reliance on electricity becomes more stable than ever before. In this video, we'll learn how these smart devices work, the technology behind them, and the significant impact they have on our daily lives. Get ready to discover the future of electrical grids like never before. Power outages aren't just a minor inconvenience, they can cause enormous economic losses. Factories, hospitals, and even homes depend entirely on electricity, and a single outage can halt production lines or threaten patients' lives. Traditionally, technicians had to travel long distances to locate faults, sometimes taking hours or even days. But now, with smart devices, everything is faster and more precise. These devices use advanced sensors and instant communication technologies with the control center, enabling real-time fault detection. The result? A faster response, reduced losses, and better electricity continuity. This technology also helps monitor the networks continuously, even before faults occur, making the system more reliable and sustainable. Smart devices designed for fault detection operate using a suite of intelligent sensors and modern communication systems. Every power line has monitoring points that measure voltage, current, and temperature. When a fault or sudden surge in current occurs, this data is immediately sent to the control center. There, the data is analyzed using advanced algorithms that determine the type of fault, its precise location, and its severity. Some devices also rely on artificial intelligence to predict faults before they happen, a process known as predictive maintenance. Imagine an electrical grid with its own mind, knowing when and where a fault will occur, and providing an immediate report. This reduces the time wasted searching for faults and makes response times much faster. There are several types of sensors used in these systems. First, there are current and voltage sensors, which are responsible for measuring any change in electrical power. Second, there are temperature sensors, which detect any increase that might indicate a short circuit or overload on the line. Third, there are acoustic and vibration sensors, which are used to identify mechanical faults in transformers and cables. All these sensors work together to form a smart monitoring network that accurately tracks everything. Data is continuously, around the clock, transmitted to the central system where it is automatically analyzed. This accuracy means that any fault, no matter how small, is detected in real time, reducing the chances of prolonged power outages and increasing grid reliability. Artificial intelligence is not just an addition, it is really the heart of these smart devices. Algorithms that are capable of learning from past data can actually predict fault locations before they even happen. For example, if the system detects a recurring surge in current at a specific point, it predicts the likelihood of a short circuit or maybe even a cable break. This means technicians can step in before an outage occurs, and that's a practice called predictive maintenance. The result? Well, you get a much more stable and secure electrical grid. Plus, repair costs drop significantly. This technology honestly makes electrical grids smarter than ever before, because they act as if they know every part of the network and keep learning from any fault that happens to improve future performance. With these smart devices, the response speed to faults is just unparalleled. Before all this modern technology, locating a fault could take hours. But now, in just a few minutes, the control center knows exactly where the problem is. This has a really tremendous impact on society, since schools, hospitals, and factories can count on a continuous electricity supply. Making electricity more reliable also helps reduce stress and frustration for people, and it boosts productivity across all sectors. Just imagine, a small fault at a power station no longer shuts down the entire city, but instead gets handled right away, as if the whole system were working seamlessly and in sync. Smart fault detection devices are actually part of a bigger system called smart grids. These grids use digital technology to optimize electricity distribution and keep an eye on consumption. When fault detection devices are integrated with these grids, power management becomes way more precise and efficient. For instance, power can be diverted from alternative sources during a fault in one part of the grid, which prevents any real outage. Smart grids also let us record and analyze consumption data for each user, so we can improve energy management and really cut down on waste. Every minute of power outage costs businesses millions of dollars. Thanks to these smart devices, outage durations can be reduced to minutes or even seconds in some cases. This significantly reduces economic losses and makes businesses more stable. In addition, the ability to predict faults before they occur helps reduce emergency maintenance costs. Such a system not only saves money but also protects critical infrastructure from damage and, ensures the uninterrupted continuation of essential businesses and services. Electricity power is always fraught with danger, and any malfunction can lead to fires or electric shocks. Smart devices help significantly reduce these risks. Advanced sensors detect any sudden surge in current or high temperature, and send an immediate alert before any incident occurs. Artificial intelligence analyzes this data instantly to determine the severity of the malfunction and sends warnings to technicians. The result? Protection of lives and property, and a rapid response to any electrical fault. In Japan, for example, these devices have been used to reduce power outages in major cities by up to 80%. In the United States and Europe, companies rely on this technology to ensure continuous power supply to hospitals and critical factories. There are also applications in remote areas, where identifying faults used to require hours of travel, but is now possible through remote monitoring. These experiences demonstrate that smart technology has the potential to transform energy management globally into a safer and more efficient experience. With the development of these devices, the future suggests the possibility of maintaining electrical grids almost entirely without direct human intervention. Robots and intelligent technicians could receive direct instructions from the system to repair minor faults as soon as they are detected. Artificial intelligence could automatically control power redistribution and anticipate problems before they occur. This means a nearly independent electrical grid, safer and less prone to failure. The future seems to be one where electricity itself becomes intelligent, capable of protecting and managing itself with astonishing efficiency. Smart devices for identifying faults in electrical grids represent a true revolution in the world of energy. From improving response times and reducing losses to protecting lives and property, and even predicting faults before they happen, this technology is radically changing our daily lives. Imagine an intelligent electrical grid that behaves as if it has an independent mind, learning from its mistakes and ensuring a continuous power supply to every home, factory, and hospital. The future of electricity is becoming safer and smarter, and any city that relies on these devices is a city prepared to face energy challenges with high efficiency.